The traditional way to introduce somebody is it's with great pleasure. It really is. John is the guy who started this, mostly out of desperation and a need, and all of us have profited by it. I don't need to say anything else. Thank you very much. Thank you. It's great to be back after a very, very long time. Unlike past times I've been to Tickle conference, I actually have glasses this time. I was trying to think about what to talk about at this conference, and I thought what I would do is mostly look backwards. But first, I wanted to answer the question, where the heck have you been all of these years? And the quote on this slide is something that occurred to me sometime in the mid to late 1990s, in fact still in probably the highest boom days for Tickle. It's harder to outlive your successes than your failures. It occurred to me that if you work on a project that fails, it ends. The end may not be pleasant, but it's over and then you can get on with your life and go do the next thing. But if you work on a project that succeeds, it goes on and on and on. Things never get easier. The bug list only gets longer and longer. And you could very quickly find yourself spending your entire career on a single project. And as much fun as Tickle was, by the late 90s I was thinking I didn't want to do something else with my life besides Tickle. I didn't want that to be the only thing. So, what happened is that when it became clear at the end of the dot-com bubble that scripting for Juba was probably not viable as a company, so we ended up selling it to Interwoven, that seemed like a good time for me to detach from Tickle and see if I could do something else with my life. So in 2000, in preparation for that, I set up the Tickle core team so that there'd be another group of people so we could capitalize on all the other people in the community that were already developing Tickle to keep it going. And then I decided to basically go cold turkey and see if I could go do something else with my life. So I'm totally out of touch now. If you were to ask me questions about what's happening in Tickle this year or even 5 years ago, I probably can't tell you. So I'll talk mostly about stuff that happened a long time ago. But the good news is I do still get all the TCT mail, and so it's easy to see that Tickle is still doing very well without me. It's great to see that I'm as irrelevant as I have become over the last 10 years. It doesn't really seem to make any difference. So I thought I'd do 3 things today. First, I thought I would tell some of the stories about the early development of Tickle. Some of you have probably heard these stories before. Then I thought I'd look back and see if I were starting again and I knew then what I know now, what would I do differently in the development of Tickle? And then finally, I thought I'd give a quick update on what I have been doing over the last 13 years since I stopped working on Tickle. And how many of you have been at Tickle conferences in the past where I've been present? So a significant number. Okay, so one of the things I like to do is do little polls. And so let's start with a poll. So the first question is, when were you introduced to Tickle? I'm going to tally up the votes here just so we can kind of get a sense of where the audience stands. So when were you first introduced to Tickle? I've got 4 categories, and just raise your hand, hold it for 4 or 5 seconds so I can do a rough count and type them into my slides. So how many of you met Tickle for the first time in the last year? Anybody in that category? What about 1 to 5 years ago? Anybody in that category? 1, 2, 3. 5 to 10 years ago? 1, 2. And more than 10 years ago? 25 to 30. Yeah. Big number. So I guess the good news is there's a lot of people that are still actively using Tickle, have been around forever. That's great. Maybe the more risky news is that there's not as many people that are new to Tickle, and so if there's some way we can figure out to get more new people, that would certainly be be great for the longer term success of Tickle. Okay, so now let me go back and talk about how Tickle got started. If you've read the intro to the Tickle book, you've already seen some of this stuff. The time period was the mid-1980s, and just to put that in context, this was the time when bitmap displays and mice were just entering wide use. I know at Stanford we were buying Sun workstations for graduate students and faculty. The PC came out in, 82 or 83, the Mac came out in 1984. So people were starting to build applications that used mice and displays, but they were still fairly primitive back in those days. And at the time, I was working on a variety of interactive tools, mostly design tools for integrated circuits, layout editors and timing analyzers and things, but also other stuff. I built a text editor in that time frame. And my experience was that every tool needed to have some sort of a command language. And today, maybe that wouldn't be as important because the mouse-based interfaces are so complete with menuing systems and wizards and stuff like that. But back then, typically, if you used a mouse at all, it only provided part of the application, functionality of the application. And you ended up typing commands to do various things. Imagine, if you think about the interface to VI, still where there's you hit escape or colon and you get a little command line interface at the bottom. So typically these programs needed some kind of command language both to complete the interface and also so people could script sequences of commands. And we found ourselves building a new one of these command languages for every tool, and they all were pretty bad. The main reason was that typically the command language wasn't the main reason we were building the tool. The tool was the main reason, the VLSI layout editor or the text editor. And so we would typically throw together a command language for that tool. They were done in a way that we couldn't really carry them forward to the next tool, so we'd build a new one. You'd copy the code from the old command language and modify it for the new tool. And they ended up not really being very good, and users complained about them all the time. They didn't have very good features, they were quirky, and so it ended up kind of being an embarrassment for us. So we always had bad command language after bad command language. So the idea for Tickle in the very beginning, and this drove most of the design of the language, as I'll talk about in a couple slides, was to build a good command language once. Somehow build it in a way where we could spend extra effort, do it one time, and then carry that language from tool to tool to tool, and not have to rebuild a new bad language for every new tool. And so the premise was, in order to be reusable, the command language had to exist as a library package. So the library package would define the basic syntax of the language, but then it would provide facilities that would be common to all command languages, things like variables, control structures, functions, and file I/O. Although I have to say, at the time, file I/O actually was not in the earliest version of Tickle. That was something that Carl Lehenbauer and Mark Diekons added with TickleX after the fact. But the idea is all the common things would be built into this library, and then you link that library into your application. And more important, you would then go and add additional new commands that are specific each individual application. And so those new features would then appear as part of the Tickle language, and the idea was to make that totally seamless so that those new commands would appear pretty much indistinguishable from the built-in commands. Wouldn't be some wart that was sort of tacked onto the side of the language. And by the way, the time frame for this was 1987. I took a sabbatical from Berkeley, and the fall of 1987 I got the idea for both Tickle and TK and started noodling around with it. So I didn't really start coding until 1988. So next poll. Question is, how many new Tickle commands have you implemented in C or C++, as opposed to writing Tickle scripts that use existing commands?
Question, is this that are in the core now, or just for any application?
No, not for any application, just new Tickle commands.
What about Tickle commands that write new C commands that are used in Tickle?
I get to count that as one. Okay, so how many of you have not implemented any new Tickle commands? 1, 2, 3, 4, 5. And how many have implemented just one? Exactly one. Nobody?
How are you counting adding a library and merging it into Tickle as an extension?
I don't know, use your best guess. You can interpret what you think is reasonable as a single command. What about having went 2 to 10 commands? A few. 1, 2, 3, 4, 5, 6. And then what about more than 10 commands? We've got some veterans here. 9, 5, 10, 15. It's like 20 of you out there. Okay? That says a lot about our audience. I was expecting a little bit different distribution on that one. Okay, so let me talk a little bit about the Tickle language syntax now. And honestly, the Tickle language syntax just fell out naturally. I spent very little time developing the syntax because it was just a natural outgrowth of the desire to have this super extensible language. But it was influenced by, probably mostly by the Unix shells, because they have actually a fairly similar purpose, but also little bits of Lisp and C crept into the syntax at various points. So the first thing is that this needs to be an interactive language. I assumed large numbers of people would be typing commands interactively. And so that meant it needed to have really simple syntax. You didn't want to have people have to have a lot of punctuation characters and open quote and close quote and parentheses and commas and stuff like that, like you'd have in or semicolons, like you'd have in a more traditional programming language. So the goal was to have really, really simple syntax. And for example, basic strings you could enter without having to type quotes around them, the same as in, say, Unix shell. Then the second thing was how to make it really easy to build extensions for this. And so that means that the interface to the extensions needs to be super simple. And I ended up using argv, argc syntax for that, again, kind of inspired by the Unix shells, where each command is just a collection of words, and the first word is used to dispatch to a particular piece of C code to implement that command. And then you just pass the words off to the command with this nice simple argv, argc array. Then the next thing is we want to build a large number of extensions, and ideally you should be able to implement anything as an extension that we could have put in the core. That there's no particular privilege to being in the core versus being out in an extension. And that meant even being able to implement control structures as extensions. So the key thing in doing this was to defer assignment of meaning to values. That when a value is entered by a programmer, that the core is not going to define what that value means. Because if it does that, then that's going to restrict the ways in which extensions can use it. Instead, the idea is that the meaning of a value is determined by an extension. That is, meaning is associated with the way a value is used, not with the way it's entered or the way it's stored inside the system. And so that meant, for example, quote by default. That is, by default, Tickle makes no interpretation of all the values. Everything is just a string. It gets passed off to extensions, and then inside the extension, the meaning gets assigned. The extension decides, is this going to be an integer or a floating point number or a Tickle command or an expression or anything else that it wants. And kind of a corollary of this is that it needs to be possible to pass scripts through to commands. Because if you're going to implement control structures, then you're going to end up with one of the words of one command actually being a totally separate script that gets executed itself. And in order to do that, then we needed, that's the reason for the curly brace quoting and nested quoting. This is an area where I think Tickle did better than the shells. Most shells tend to have quoting that does not nest very well. And for Tickle, it was really important that the quoting nested naturally to any level. So you could have scripts containing scripts containing scripts containing scripts, and so on. But basically, all this just fell out once I decided you wanted to be able to type interactive commands and you wanted powerful extension mechanism. There weren't really a lot of decisions to be made. Everything just kind of fell out. That was very easy. So then, one of the side effects of this is that Tickle has, think of it as a two-level syntax. At the top level is the basic syntax of commands, words and substitutions and quoting. And this is really, really trivial, really simple. You've all seen it. There's a one-page description that can pretty much describe the whole thing. Then the second level is defined by the individual commands, where any command can do anything it wants. There's no forced requirements or forced commonality among the commands. So the commands assign meaning to their arguments and define their own behavior. And one of the interesting side effects of this, think actually sometimes confuses people when they're learning Tickle, is that every command you can pretty much understand independently of every other command, because they're all relatively self-contained in the way they take arguments in and assign meaning to them and carry out their function. But the result is that almost all of what you think of as Tickle is really it's the commands, not the top level parsing stuff. There's almost nothing there. And so just to restate the obvious, a simple command like this, you end up with 1, 2, 3, 4, 5 words in the command. One word is actually this huge inner script. And of the words of the command, let's see, one of them is a command name, 3 of them are scripts, and then the last one is a Tickle expression. And of course, it's totally up to the for command to actually apply that meaning to those. Some other command could take the same arguments and do something totally different with them. Okay, so now I have one more slide. I have a bunch more polls. I think one of the most controversial aspects of Tickle is, why is everything a string? And I think that's something that new people find surprising and takes a while to get used to. And the reason for that, again, gets back to the notion of extensibility, that every individual command should be able to decide what its arguments mean. The meaning should be decided by the commands, not by the interpreter. So that means that, for example, extensions can introduce new data types if they want to, and many of them do, have totally new ways of interpreting their arguments. That's the first thing, so for extensibility. The second thing is it's really great for integration. If you want to tie a whole bunch of things together that weren't designed with each other in mind, and you want to pass values back and forth between them, then you need some common, uniform way of passing those values around. I'd argue if you have a strongly typed system, it makes that kind of integration difficult because everything is different and non-fungible, non-interchangeable. But the cool thing about everything as a string is that everything is interchangeable. So for example, one command can receive an argument and pass it on to another command without having any idea what that thing is or how it's eventually going to be interpreted. So the result of this, I think, is that having a sort of universal data type makes integration really easy. But the seamy underbelly of that is that this is not very fast. And I think making Tickle fast has been a challenge over the years, in large part because you can't tell anything at the top level. Until you get down into a command, you don't really know what something is, and so it's hard to optimize the implementation of that or compile that down to efficient code. All right, so now I have a bunch of polls about the language syntax. So first, overall, this may be a prejudiced audience here, but how do you feel about the Tickle language syntax? So you can rate it from love it to sort of ambivalent to hate it. So now it's like Listerine, hate it twice a day. So how many people here actually love the Tickle language syntax? 25. What about like it a little? 1, 2, 3, 4, 5. Ambivalent? 1. That's an awesome person, Jeff. Let's all get enough for the session. Dislike it a bit. At least a few. And what about hate it? Because maybe you wouldn't be here if you hated it.
I'll take Larry's proxy, put down 1. I'll take Larry's proxy to put down 1.
Yeah, sure, why not? Okay, next poll. This may be hard for some of you to remember. It's so far back for a lot of you here, but how hard was it for you to get comfortable with Tickle when you first started? Did you find it really, really easy to learn, just totally natural, or very, very difficult? So let's start with extremely easy. How many people found it really easy to get started? 1, 2, 3, 4, 5, 6, 7, 13. What about fairly easy? 13. Neither easy nor hard. 1, 2, somewhat hard. 1, 2, 3. And what about really hard? Okay. And then the last poll in the syntax. Do you think Tickle's syntax helps or hurts adoption? So you can rate anywhere from, it's a huge positive benefit, it's one of the things that drives adoption, to it really, really, really hurts adoption, we have to get over it in order to get new users. So how many of you would say the syntax strongly helps Tickle adoption? 1, 2, 3. Helps a little bit, but not a lot. 1, 2, 3, 4, 5, 6, 7, 8. Neither helps nor hurts.
Can you have both helps and hurts?
Yeah, it has its two audiences, right? I mean,
Yeah.
and they balance out, right?
Sorry?
So, some people, it actually drives adoption a lot, and then for a lot, it drives them away, but sort of equalizing.
I see. So what you're really voting is 50% for strongly helps and 50% for strongly hurts?
Yes.
Yeah,
That's who you're looking at.
Yes. It's always got two audiences. The audiences of the people programming extensions in Tickle or programming Tickle to do an application, and then the end users who are maybe scripting a little bit in it, who aren't computer science people. So the people who aren't computer people, they find it easy. The ones who are kind of struggle because they keep wanting syntax that's not there, and they're just
Show me the
assuming it
BNF.
is.
I see. The more you know how to program, the harder it is to learn Tickle?
Yes.
We didn't finish the voting. So we got down to neither helps nor hurts now. Hurts Tickle adoption a bit. 9, 10, 11. And hurts a lot.
What boy, Proxy?
Okay. So I think many people have heard the Tickle origin story before. I thought I'd talk a little bit about TK, because I don't think I've actually talked much about how TK came about. And actually, as I was putting together my slides, I managed to dig up some of my old notes that I made to myself back when I was designing TK. So I'll talk a little bit about that. So the reason TK came about, honestly, I had this thing about wanting to do a Windows system for ages. And it had been thwarted at every turn. And finally, with TK, I sort of got to do kind of a Windows system, or just a toolkit for one. So we'd initially started to build a windowing system as part of a project called Sprite that I was leading at Berkeley in the mid-'80s. Sprite was an operating system for workstations. It was one of the first network operating systems, and its main claim to fame was a really fast network file system. But I really wanted us to build a Windows system as part of that project. And this was around 1985. In fact, we started to design one. Honestly, the graduate students of the project were a little bit nervous about this because Sprite was already a pretty ambitious project, and doing a Windows system on top of that, that would have been pretty difficult. And then the X Windows system arrived on the scene. I think it first appeared in late '84, and about the time we were starting to do our own design, the grad students all latched onto this and said, please don't make us build a Windows system, we just use X. And we looked at X, and unfortunately, X was good enough. It's probably at least as good as anything we would have done. And so we decided we'd use X for Sprite. I say unfortunately because actually it was totally the right decision for Sprite. I'm really glad the graduate students talked me out of it. But it was disappointing for me because I really wanted to build a Windows system, and now we weren't going to be able to do that. So we started using X, and then around that time, I built a very simple toolkit. Actually, I think it was originally for X10, not X11, called SX, a simple toolkit for X. And I used that in a couple of applications I built for myself, most notably a text editor called MX, mouse-based editor for X, that ended up causing me to get RSI in my left wrist, and I've been able to type for the last 15 years because of that. So SX was a fun experiment, fairly limited in functionality, but it kind of got me excited about doing windowing stuff, and it was still trying to do this thing about something related to Windows systems and toolkits. And then X11 came out, and along with it, the XT toolkit and eventually Motif. And there was great news here because both of these were just dreadful. Worse than you could possibly imagine as programming systems, which made me so very happy. Because now there was an opportunity to maybe actually do something in the windowing world. And so at the same time I was thinking about Tickle in the fall of 1987, I started thinking, could you build a toolkit as a Tickle extension? Tickle's really extensible. This would be a really great example of an extension to build. So then the question was, how to do that? And actually, this was a much more interesting design exercise than the Tickle command syntax. That's like one day the Tickle syntax all fell out. The only question for Tickle was, what are the quoting characters you use? Do we use curly braces for quote and square brackets for commands, or vice versa? But there weren't really a lot of choices there. But with TK, the question was, how do you combine widgets with the Tickle command language? And in particular, the trick was that each widget needed to have its own set of commands that could apply to that widget. And so I wasn't really sure how to do that. And when I started putting together the talk, I could remember there were a whole bunch of different things I thought about, but I couldn't remember what they were. But I managed to dig up my notes and found some of the early ones. And actually, the first idea I had was to have a separate interpreter for every widget. Because interpreters have commands, widgets need to have commands. That seemed like kind of a natural thing. And then each widget action would have been a separate command within that interpreter. But then at this point, things started getting kind of complicated, because if you're going to have a whole bunch of widgets, you want to really end up redefining the whole command set for each instance of a widget. So I thought, well, if we're going to do this approach, then there should be some way that the widget interpreter can inherit commands from some sort of shared, class interpreter, so we wouldn't have to be redefining all these commands. But then, where do you put the commands that aren't really dependent on one widget, like pack command, and how do these widgets communicate with each other when they're all in different interpreters? And so that one eventually gave way to the current design, but at the time I was really uncertain what was the right way to go. There were sort of several different competing designs, and decided to go with, of course, what we have right now, which is there's one interpreter per application, not per widget. And then there's two kinds of commands for widgets. There's a class command for each type of widget that's used to instantiate widgets of that type. And then there's a separate widget command created dynamically that represents each instance. And I think the big new thing here that I hadn't done before in Tickle was the idea of having multi-level commands now. Originally, I thought a command has some opcode as the first word and then arguments. But with this scheme, what ends up happening is you have multiple words of opcode. There's a top-level opcode, let's say selects the widget, and then there's the next word is used as the action, or some second-level command that would control the particular command for that widget. And I think we even have Tickle commands now that have 3 levels or more of commands in some of them. But that was the key idea. So this was something I noodled over for a long time, weeks, months, trying to figure out what the right way to go was. And actually, in the end, this design is one of the things I'm happiest about Tickle. That worked out really, really well, and I'm not so sure this other one would have worked very well if I'd gone that way. So that was a really interesting design exercise.
Did TK force client data into the interface, or was that already in
Good
place?
question. TK force client data into the interface. No, that was already there. That was something I've been using for years in various other kind of callback interfaces. That whenever you do a callback to something, you always need to provide some sort of opaque client data. So that was one thing about TK. Then the other decision I made very early on, which I'm really thankful for, is that I decided from the beginning that absolutely everything in TK has to be dynamic. That is, anything that you can specify about a widget when you create it, you should be able to change after the fact. Nothing should be static. And one of the things that bugged me about other toolkits is that so much stuff was static. You had total flexibility when you created something, and then you're stuck with that forever. You couldn't change it once you got the thing up on the screen. And so this everything must be dynamic, then influence things like the designs of the canvas widget and the text widget, so they end up being very dynamic widgets. Okay, so that's some of the basics of the early days of Tickle. Then there were several things that surprised me. Tickle and TK went in directions I had never foreseen. I mean, the first direct thing that surprised me is that anybody besides me actually wanted to use either one of them. I built these totally as a project for myself. And there were really two reasons for doing Tickle. I think only one I've maybe admitted publicly. The first one was I had this problem of command languages and tools we were building, and hadn't heard anybody else talk about that problem. It seemed like that was just something that was just me, because I was building lots of different tools. But the second thing actually was I wanted to write the whole thing myself. I wanted a system I could build that I would write completely, that no one else would write. In particular, all my other projects at the time were done with graduate students. And I enjoyed working with graduate students. Those projects were a lot of fun, but the students needed to get PhDs. I didn't, I already had mine. And so they got to write all the fun parts of the system. So in Sprite, I wrote the malloc and the kernel call interface, and the students got to write the caching file system and process migration and all the really fun stuff. So one of the reasons for doing Tickle is I wanted a project where I could do all the fun parts. I was happy to do all the, the grungy parts too, but I wanted to have the fun as well. I have lots of water here someplace. Thank you, Jeff. Cliff, did you take my water?
I put it on the bench, but I don't know where it went.
Oh. Anyhow, thank you, Jeff. I'll get a new one.
John?
Apparently I've seized it, but mine has.
I won't tell you what I did to that water.
But you should go get some strong antibiotics.
So as I think most of you heard me say before, I didn't really think anybody but myself would care about Tickle. And I didn't really do much to advertise it. I was trying to think, when did I first start talking about it? I think it was that Berkeley has an industrial liaison program for various companies that fund projects in the computer science and E department. And there's an annual meeting every year where they come in and we give talks. And I suspect there was a year where I didn't have a great idea for a talk, so I figured I'll just talk about this Tickle stuff I'm doing. So I gave a talk, and actually it was fairly well received, and some of the people that were from companies there invited me to come out and give talks at their companies about it, and so I did that. And then people started asking me for copies of the code. And that was surprising, although not too surprising at first, because these were places where I'd given talks. And then I started getting requests from people I'd never heard of before, just random people falling into my mailbox asking me for copies of the code. And that was a huge surprise. And then I think the next step in the development was I wrote a paper for Usenix and gave a talk there. And I suspect most of the next step in development came from Don Levis, who was at the Usenix talk, which I think was 1990. And back in those days, Usenix was every 6 months instead of every year. And so Don heard the talk in one Usenix and was so excited, he ran back, decided he was going to try and build Expect and publish it in the next Usenix 6 months later. And of course, you have to submit your paper like 3 months before the conference. So you have 2 or 3 months to get Expect done, which he did, and had a paper in the very next Usenix on it. And I think most of the early adoption of Tickle then all came from people wanting to use Expect. There was no TK in the early days. TK came about a year or a year and a half after Tickle. And of course, you know many of the other players, Mark Diakons and Carl Leinbauer, that did Tickle X, Michael McLennan with InkerTickle, and so on. And at this point, once other people started making contributions, then they became evangelists for it, and of course, the whole thing exploded, and the rest is history. But it was certainly a huge surprise for me, probably one of the most fun surprises of my career, to see this little thing that I had no expectation for just turn into a huge phenomenon. It was really fun. The second thing that was surprising, though, to me was the rise of the shells. That Tickle ended up being used in ways that I had not expected. I designed it as this embeddable command language. So what I thought that meant was that a typical use would be that you write an application of which Tickle is a small piece. The application